To get started doing data science, I have curated some real-life data sets from the building industry that we can use to practice the skills covered each week. In this video, I'll give an overview of those scenarios and an understanding of how they fit in the life cycle of buildings. In terms of teaching style, this course is different from other programming options on the edX platform for a couple of reasons. The first is that we focus on the analysis of actual data from the built environment. You'll be loading, processing, and visualizing data from buildings within your first few lines of code. The second thing is that more time will be spent on what we call high-level programming. In a traditional course, we would first break down all the Python concepts and explain each one before doing anything practical. In this course, we're going to get started more quickly to show programming as part of a process. You may want to review Python fundamentals during or after the course to refine the knowledge gained, perhaps by completing a general Python course in parallel to this one. There are two ways to use programming in the built environment. The first is to use scripts or programs to automate a process or system. For example, in digital fabrication, you might have robots that respond to a Python script that tells them how to assemble or fabricate something in an automated way. The second way of using programming is for the automation of data analysis tasks and decision making. This is where you're using code to take raw data and transform it for a certain objective. In this course, we're going to focus on this second type of coding. The first data set we'll be using is focused on the design of buildings. In this phase, we will practice using whole building energy simulation data that is used to predict the performance of a building before it's constructed. How much energy a building will use is based on the input characteristics for this model. The data set for this context was created from the output files of the popular Energy Plus simulation engine. These files are part of a workflow of parametric modeling in the design phase of a building. The goal is to use these models to compare the predicted consumption of different options as part of the integrated design process. The second data set that we'll use is from the construction phase of the building lifecycle. In modern commercial buildings, there are sensor networks installed in a building that control systems such as lighting and air conditioning. One of the goals of the construction process is to confirm that these systems are working well before being handed over to the owner. This process is called commissioning. These sensor networks are essentially modern Internet of Things, or IoT systems, and Python has specific libraries devoted to this type of data. The IoT dataset that we'll use in this course is from the Building Data Genome Project, an open source data repository which focuses on measured sensor data from actual buildings. The primary IoT data that we will use is from electrical power meters. Finally, in the operations phase, we will focus on processing data related to the comfort and satisfaction of building occupants. This dataset is from people who have given their feedback on how comfortable they feel in a space. They've indicated that they feel too hot or too cold in a certain scenario, and these responses have been combined with sensor data such as zone temperature and humidity. The specific data set that we'll use for this purpose is from the ASHRAE Global Thermal Comfort Database 2. This data set provides empirical occupant feedback data from thousands of people who participated in dozens of different thermal comfort studies performed around the world. In addition, each set of videos in this course will include an overview of how these different techniques have been implemented in a particular case study right here in Singapore. This case study is SDE4, a net zero energy building here at the National University of Singapore. I will give you an introduction of how data science was used at each phase of this building's life cycle.